All right, this is Nathan Schneider with Video Project 2. Got my Bearcat card here, and I'm going to get right into it. So I was doing problem 4, since my last name starts with S, and this is going to be a long one, so it's pretty hard to squeeze in 6 minutes, so I'm going to have to go kind of fast. But given the function x cubed minus 3x squared plus 2x over 2 to the x minus 20, find and classify all relative extrema for f of x on the interval negative 3, 3. So first step of that, I'm going to show you my notebook paper that I worked off of. Oh, no. Oh, there we go. Okay, sorry. So looking at this, we know that this is a quotient rule. Quotient rule is gf prime minus f g prime over g squared. So first thing I do is find f, g, f prime, and g prime, and then assemble them into this quotient rule formula. And we get 2 to the x minus 20, which is g, times 3x squared minus 6x plus 2, which is f prime, minus x cubed minus 3x squared plus 2x, which is f, and then times natural log of 2 times 2 to the x, which is g prime, all over g squared, which is 2 to the x minus 20 squared. So first step is to use solver to find the critical points or zeros of that derivative function. So I have that in my, I gotta turn this on. I have that in my, oh my gosh. I have that in my y1 right here, this whole giant formula. And when I hit graph, it's going to show y2 and y1. But this first graph here, this is y1, which is that derivative graph. y2 is going to show up. I had to put y2 in there for tables later in the problem. But this first curve is the f prime graph. And it's going to pull up y2 here in a second, but we don't need that for right now. So when I was first looking at this, I had zoomed in on right about here where it gets flat and determined that it looked like there were zeros at 0.5 and 1.5. So when I went into solver, those were my guesses. And it spits out 0.428 and 1.591. I'll do it as quick as possible. So start with 0.5. Y1's already in there. Gives me that, which is one I already have. And then if we do 1.5. No. 1.5. It gives me 1.591. At least it should. Yep, 1.591. And then using those, now that we have critical points, we have to make a sign chart. So I did that in this table. The points I chose, we needed one to the left of 0.428, so 0 gave me a negative. In between the two, 1 gave me a positive number. And then greater than 1.591, 2 gave me a negative number. And all those values are right here. So there's our sign chart. Now we know where our relative minimums and maximums are. If we're going from downward to upward, we have a relative min. If we're going from upward to downward, we have a relative max. So now we need to find the y values or the function values, which are also in the same table in the y2 column, my two critical points right here. And then they're given y values that make the points that go to the relative minimum at 0.428, negative 0.021, and the relative max at 1.591, 0.023. So now we need to find absolute maxes and mins, which is easier if you've already done the relative ones. So this is the table that I made right here, which is in the calculator. There's negative 5, 1, and I already had 0.428. And these are the y values that it gave me for the original f function, the f of x, not the f prime. So find the highest, find the lowest. That gives me an absolute max at negative 5, 10.516, and absolute max. I don't know if I said that. At negative 5, 10.516, and an absolute min at 0.428, negative 0.21. And again, we got those y values from the original f formula using this table. And that makes sense. Where the f function value or y is highest, that's your absolute max on that interval, and where it is the lowest, that is your absolute min on that interval. So it's not just the math, it does make logical sense when you think of it on a graphical sense. But those are my absolute maxes and mins. Oh, and we also did have to drop 1.591 because it was not within this interval. But yeah, that is video project 2. Thank you.